here's the time of day. This is going to be Biosphere 2 tour. We're in the rainforest now.
We're going to come back to that. Okay, move to the back so everyone can get in the rainforest. All right, this is the tropical rainforest. These plants have been growing in here for 20 years, 22 actually. Oh, it's different today. The humidity is different. This rainforest, by the way, is modeled on the Amazon. Whatever is happening in the Amazon right now at 11:55 down in South America is happening here. And it's raining a little bit in the Amazon, and so it'll be raining a little bit. It's just as though you've taken a Boeing 707 and went down to South America. Okay, this thing goes back approximately 85 yards. It's 20,000 square feet. You folks are wondering if there's animals in here. There used to be bush monkeys, but they were getting into the machinery and the scientists had to put them in a zoo. Okay? But there's millions of insects throughout this biome. There's also different types of other small vertebrates, like mice and frogs and those lizards and that sort of stuff. But there's no boas, no big rock reptiles or birds, cockatoos and stuff like that. Okay? Now, rainforests house approximately 60% of the plant and animal species on our planet resides in the world's rainforest. Rainforests also take off the surface of the globe 28% of the harmful gas of carbon dioxide, and they provide us with about 28% of the oxygen that we breathe. What are they doing in this rainforest? They're studying the photosynthesis of these plants at the canopy, how they take in sunlight. They're also studying the root system. These plants make a number of different gases as they come in contact with soil. They make ethanol, methane, and ammonia. Also, they're going to be studying something else in this rainforest. Scientists now believe, without arguing, that our planet is warming and will warm 7 degrees during the next 25 to 50 years. With that, we are going to have extreme weather anomalies, and with that, we are going to have periods of drought. So they're going to do a drought study in this rainforest in late spring. Any questions? Yes, ma'am.
What controls the environment? Obviously computers or something?
Oh, let me ask her a question.
Oh, I'm sorry.
Okay.
I wonder about back there when you said that they grew all their food. One of the ladies on that video said that one thing that they were missing was calories. Why is that?
I wish you had asked it while we were sitting there.
Sorry.
Because I'm already into the rainforest thing.
I know.
They would have benefited if they had avocado trees as well as olives and some additional grains.
Fats.
Pardon?
Fats.
Fats, yeah, they were mostly vegetarians. When I said that, they didn't eat the grease of the animals they cooked. And you had a question, sir?
What controls the environment in there? What tells
Energy
it to rain?
center.
No, I know, but what tells it that, you said it mimics the Amazon at 11?
They're computers.
So whatever.
They're computers.
So the computers are telling it to rain or to be hot.
Okay, let me explain something to you. They have instruments in South America throughout the Amazon forest. And what they do is they're looking at what's going on in the Amazon on their computers, and then whatever is going on there, they mimic it. By the way, they don't put any fertilizers or chemicals in this rainforest. The cousin plants are growing next to each other. That's the reason this is so lush. The only thing that the scientists provide is the water and the sunlight that Arizona provides. So these plants actually think they're in the Amazon. That's why it's so lush. Okay? Okay, we're going to go to the ocean. Yes. Yes. He asked if there are any tarantulas or spiders. No, there are not. In some of the other biomes, some tarantulas do get in, and there's other spiders outside. Not in this one because anything that's dangerous, and tarantulas are not, all of the poisonous and very dangerous ants as well as spiders weren't brought into this biome, okay? We're gonna go to the ocean. Last person, yeah. If you could close this door, because this is a separate biome than the ocean outside, okay? If you could, thank you. Follow me.
Ocean tour.
Here, you got plenty of time to take pictures. Okay. The research is, by the way, before I talk about the research and talk about this ocean, it's 25 feet at its deepest point. This water is salt water. It was brought in from off the coast of San Diego, California. Not only did they bring the seawater, they brought all the living creatures, the plankton, the coral, the fish, the sea grass, the oil, the sea weed, the plants, all of those things that come down there are the sharks and the giant coral. And there's little plastic bottles and backpacks. We've used so prolifically that many businesses, like business, Jimmy Peanut Butter, put their product in plastic as well. Many of these are carrying water bottles today where they have plastic. Plastic is very good for us in the United States and as well as other countries. And they used to dump a lot of garbage into the Pacific Ocean in the 50s, 60s, and
We're leaving the ocean now.
swamp or a wetland area. These are mangrove trees. We're going to talk about those, okay? If you can all see, I've moved some folks down so you all get a look. Okay. The saltwater marsh is usually to our left, over on this side. Mangrove trees can grow either in salt water or fresh water. It makes no difference to them one bit whatsoever, as long as they get moisture. And the freshwater marsh would be to this side. To my right, this would be where trees and mountains and hills, where streams and rivers would come right down through the dry part of the land, right through the marshlands, okay? Marshes are very, very essential for the ecology of the ocean because they act as the kidneys to the ocean. They prevent a lot of impurities such as fertilizers and heavy metals from getting into the world's ocean. Marshes also are a habitat for a lot of endangered species. The tree frog, the honey flower, the crayfish. Marshes also are good for farmers because they keep a lot of the topsoil from being washed away. Okay, very essential for the world's ecology. In places like New York and Florida and Louisiana, they learned the hard way. How are you from that area? You are? You're shaking your head. You know what they did? Yeah, they learned the hard way about marshlands, Louisiana, Florida, and New York. Builders, especially in Florida, wanted to make a lot of money. They know people like to live close to the ocean. So they got their commissioners to say, look at the marshes, it's ugly, let's get rid of it. They got rid of some of it, built these big old homes on the ocean. During inclement weather, storm surges came along and just took those homes away. Today it's illegal to cut any of these trees down in Florida. They're rebuilding, and New York as well, and Louisiana. They're rebuilding their marshlands. In 2008, in Indonesia, they had a tsunami, a giant wave that came and they hit the shores that killed thousands. They had a huge marshland, but because of that marshland, thousands or more would have perished if they didn't have it. So they're very essential. Gentleman asked me about the climate inside the biosphere. When Arizona is hot outside, 115, 20 degrees, what happens inside here? Absolutely not very much. It stays relatively the same because of the climate. Like in the rainforest, this area, and the lower savanna has to be controlled. Even though some of the windows have been removed, they do keep the climate relatively temperate, okay?
We're leaving the marsh. Going to the desert.
They want to know, other folks want to know what's going on. So come on, if you take a picture, follow, keep walking. So everybody else what's being said. This is what is known as a fog desert. This is totally different than the desert of southern Arizona. These deserts exist in places like northern California, northern Chile, Baja California, Madagascar, and the Canary Islands. A fog desert meaning that these plants do not get any rain. The only moisture they do get is usually in the wintertime, and it comes in the way of fog, and also they get the condensation off the ocean. The ladies are probably wondering, wow, these plants look like they're dying. This is spring. Actually, these plants do not get real green. When you come out, your eyes have seen all of the lushness of the green in the rainforest, and you see this. It's a big change. This is the greenest these plants do get. It's late March, isn't it? Yeah. So this is a normal desert. The closest desert that you would see something like this would be between San Diego, California and Yuma, on the coast where there's a dune desert would be very close to it. And if you drive along the coast, you'll see a lot of the same plants, and it's very temperate, doesn't get too hot, doesn't get too cold, there's usually a slight breeze, and it hardly ever rains. That's what a fog desert is, okay? Now we're going to turn around, and before we do that, remember I mentioned something about the concrete curing? All of these caves, man-made caves, even the giant boulders that you see throughout these biomes, that's man-made concrete, and that was one of the big problems they had. Inside the closed system, that concrete was taking oxygen out of the air when the 8 were locked inside here. So they used a lot of it, so you can see it presented a problem. It takes a year for concrete to actually cure and dry up, okay? Now we're going to look at this structure. These look like incubators on top of this platform. The research project here is called the weathering of rocks. Some of you in the front, if you look down on the table, you'll see some of those rocks that the scientist is using. He's using 4 different types of rocks he's chosen from the mountains of northern Arizona. And what he's done is he's broken these rocks down into small pebbles, and he sterilized them, and then he puts them inside a sterile system. Then he's taken 2 different types of grass seeds that normally grow in the mountains of northern Arizona. He's taken off the shell and the husk, and he's put these grass seeds on top of the rocks inside a sterile system. Then he introduces sterile water. And he allows that water to drop on top of the seed that's sitting on top of the rock. So as that plant germinates, starts to grow, that root system comes out. And it grabs hold of the rock. And that rock becomes like a frozen can of food, and that plant actually disintegrates that rock, and that rock becomes soil. Okay? And how long does it take? In this research project, it takes about a year, but in the natural world, it takes about 10 years. Now, if you have good vision, and if you're tall enough, you can see little blades of grass growing up there. You can see little blades of grass. If you look harder, you got the vision to see. Okay? Any questions? Okay, we're going to go down now, and we're going to look at the machinery that runs the biosphere. Look and we're going to pass air handlers. They look like giant swamp coolers, okay? So I'm just going to warn the ladies. Your hair is going to get blown around a little bit, so it's a little cooler. You'll get cooled off anyway. So follow me.
Be underneath the biosphere. The system that run it is like 65 degrees in here. Here's an air handler, it looks just like a swamp cooler.
Hold on to it. Hold on to your stuff.
It's really cold here. There's a tunnel. Exit. The inner workings of the biosphere. Home, exit, high voltage.
We're not going to keep you from doing anything. It's just that we wanted to get everybody into the rainforest because there's tours coming behind us. All right, is everybody here? Okay. This big machine is called the Technosphere. It controls the temperature of the water inside the biosphere, hot, cold, and normal. It also controls the electricity that goes throughout all the biomes. Now, this is about the size of a train car. This was specifically built for the biosphere, because remember, this was a new project. They were doing something that never been done before. Mr. Bass had all of these scientists, engineers do things that they didn't know what they were doing at first, but they managed to do it. Now, if you look at the size of this machine, this is not the only one. There's actually 26 giant machines like this. Another one right there. They're all over the biosphere. And before we leave, if you get a chance, you like looking at machines, look through that window. You'll see 26 giant ones and 26 small ones. They go on and on and on forever. And then you'll see big old giant tanks where they recycle a lot of water. All the water in the biosphere. A lot of it gets recycled. Not all of it gets recycled, but a lot of it does. Water goes to specific biomes inside the biosphere, depending on what biome that water is supposed to go to, and it's treated differently. If it's rainwater or whatever it's supposed to do. Okay? Those folks are taking a look. If you get a chance, take a look. We're going to be walking down to what is called
zoom lens.
We're going to look up the little map and look at that
Maxed out.
round spherical round building with the white dome on top that you saw outside. From the parking lot, we're going to be going down to it. There's a long tunnel. Now, once you start to listen to me, stay on the Great Path. It slopes down, so stay on the Great Path.
We're going to the south lung. Here's another low access. We're in the south lung.
Brought here by Area 51 into Lake 50. This is a flying saucer that aliens lost for some reason. So Area 51 shipped it over here for us to keep. You don't believe me? You're laughing at me. You think I'm kidding? I am. Okay, the water that you see is just runoff. It's runoff from the irrigations inside the biomes inside the biosphere. But they want to keep the water here because the black material that you see is rubber. That rubber is supposed to last 100 years. They want to keep it malleable. Okay? That rubber lifts that saucer up in the air and it descends. When the pressure in here is higher and the temperature is warmer, the rubber membrane will lift that saucer up. It can go as high as 65 feet in the air. When it's cooler and there's less pressure, it comes down. So it moves back and forth. When it was a closed system, like your lungs, The Biosphere has two of them. You're going to see the other one when we leave this building. It's outside. It's a giant diaphragm, okay? Relief valve. It kept the Biosphere closed system where 4 things recycled. If you could think of a balloon with all the air inside it and tie the end of it, there's no place for the air to go. This was the relief valve. If they didn't build a lung system, the Biosphere would have had all of its glass blowing out like that. Like that. You understand it? Okay. Lung system. Now when we open that door, this thing will start to descend and it'll come down a little bit. The longer we leave it, it'll go all the way down to the floor. Now when it's cooler in the morning, it is much lower. During the day, it goes higher and higher, depending on how many tours come. And it sets up here. And then as it cools during the night, it starts to come down. It just goes back. We want to do a loud hello on the other side? Okay, on the count of 3, do it really loud. 1, 2, 3.
We're on the outside of the lump. We're gonna exit the lump.
All of what's going on inside the Biosphere is the energy center. That's it right there. The building with the 5 humps. That's where the scientists and engineers monitor their computers and control the Technospheres, those big machines that you saw inside the basement. They control what's happening to each of the biomes, what's going on. When this was a closed system and the 8 lived inside, they operated this system with 2 giant caterpillar generators. But they found that it was cheaper to go on the grid, and now they get most of their energy since it's no longer a closed system, and they're not doing that experiment anymore. And the University of Arizona is going forward with future research. They found that it was cheaper to go off the grid. And they get most of their energy from the little town north of us called Oracle, okay? Now, some of you have noticed some of the solar panels. What that is the University of Arizona is only using about 2% solar. There's 3 businesses, solar businesses, that are competing for a contract to do business with the university. So they're testing their solar panels on the property of the Biosphere. So when the administration makes a decision, they're going to pick one of these companies, and they're going to be using more solar in the future. By the way, before I start talking about it, they have instruments in the natural world in places like here in Arizona. There's a mountain called Mount Lemon. Then they have instruments in places like the Four Corners, in other states where there's hills and mountains, also in Mexico and South America. What they do is they collect what's happening in the natural world in real time, and they bring that data back and they compare it to this controlled study. Scientists do not know how fast water goes through hill slopes and mountains in the natural world. You know, what is the energy cycle of water? How fast does it take a cloud to rain over a mountain or a hill, to go through that process and then go back that water goes back up into the sky and becomes cloud again. They call that energy cycle. They're measuring what they call the carbon cycle. Also, there's a lot of things that take place in the soil that they're measuring right now. The soil at different areas inside the earth and soil will conduct heat for no apparent reason and just start getting warm at different parts. They're researching that. Also, our planet has different types of gases that are passing through it all the time. Okay, any questions? Okay, we're going to go up to living habitat. Follow me. On your left, you'll see a little video that's playing. One of the 8 was a doctor that talks a little bit about him and his office. There's also an apartment up there. You can look at that apartment, you can only look through it through the glass. You can't see the bed because it's like a loft that's up, okay? And there's more. You walk up those stairs, next to the apartment on each side, there's a restroom, so if you need to use the restroom, as you can see, these folks are doing their self-guided tour. You can do that, or you can go back downstairs. There might have been something you missed. You can go back downstairs and review that. Or you can go back down and go outside to the foliage and look at those panels in depth. Then you can also go to the ocean viewing gallery. You remember I said there's fish in that ocean? Well, you can actually, this is also the way to go home. You go out this door, just push real hard, it will open. Walk down the path, past the rainforest, turn right. You can just go around the corner here and look at the site. It will take you down to the ocean viewing gallery downstairs. There's also restrooms down there as well. The University of Arizona would like to thank all of you today for coming because you are supporting present day and future research on the ecology of our planet. Thank you very much.
Thanks, Mark.